Hey, it's Mr. Peterson. This screencast is about energy flow through ecosystems. Life requires a constant flow of energy. Without it, what would happen to life? Well, it'd probably cease to exist. What would happen to you if you didn't have energy? Well, you'd be hungry a lot, and that just wouldn't be a good thing. No one likes to be hungry. So, we're a lot like an ecosystem. Anyway, so where does the energy come from? Well, it initially comes from the sun, and that energy gets captured by some photosynthesizers, and then that energy flows through nature. Yeah, flow it does. Energy it must. So here's a quick food chain. So over to the right, you can see this cheetah, and the cheetah is going to eat the gazelle. Where does the gazelle get the energy from? It gets the energy from some kind of plant matter. But where does the energy initiate? Yeah, the energy initiates from the sun. So there's some solar energy, energy that comes from the sun. It's trapped by a producer in the form of chemical energy. And the chemical energy is passed on through the gazelle and then eventually winds up in the cheetah. Well, you'll also see that there's some heat involved. So there's a lot of energy that's just lost as heat. Organisms are not very efficient. So heat is lost by the trees, heat is lost by the gazelle, heat is lost by the cheetah. So energy winds up going a lot of different ways. And, and eventually when all those organisms, the gazelle, the cheetah, and the tree die, there's going to be some decomposition that goes on. And that's even going to give off heat in the end. So in the end, we're going to all wind up decomposing, giving off some heat. Kind of a sad thought. But producers. So organisms that collect energy and are the source of energy for an ecosystem are called producers. They get their energy from non-living things. So that means, what does that mean? Because we get energy from dead food, we're producers? No, not really. But we're autotrophs. I'm sorry. We are consumers. We are not producers. So producers are also called autotrophs. Autotroph means self-feeder. So they make their own food. So our planet is covered with autotrophs. Autotrophs in the ocean, autotrophs on land. Here's a little animation. NASA a few years ago sent a satellite out into space, and the satellite caught some fluorescent light that's given off by plants when they do photosynthesis. So the satellite's flying around our planet looking for fluorescent lights as evidence of photosynthetic activity by plants. So the red is indicated some photosynthesis. So there's a day, there's a night, there's another day. So photosynthesis going on, evidence of the fluorescence indicating lots and lots of photosynthesis going on. We, on the other hand, we don't do photosynthesis to get our energy. We're consumers. And so from once living things, that's where we get our energy from. And we're called heterotrophs. Hetero means other, heterotroph, other feeder, so as opposed to an autotroph. So here's some kind of insect that's getting some pollen from that flower, a fungus that gets its energy from something dead, or even carnivorous caterpillars that can catch flies. We always thought caterpillars were nice, friendly guys, but that caterpillar looks kind of nasty. So it's a heterotroph. It's eating another heterotroph, that fly. Oh, let's watch him again. Killer. Ooh, crazy. All producers have to get their energy from sunlight. Almost all producers, and that's where we're going to spend our time talking about photosynthetic organisms that take carbon dioxide and water, and they make C6H12O6, which is glucose, and then give off oxygen. So we're going to spend our time talking about photosynthesizers. So they take light energy and turn it into chemical energy. And going along with that, they create a lot of material, and that's called biomass. So as you go through an ecosystem, the chemical energy decreases, the biomass decreases, over and over and over again until we finally get down to us and there's hardly any biomass and chemical energy left. What has happened to it all? Well, most of it is given off. If you look at those top arrows, most of it is just given off as waste energy. So it's lost as heat. Most of the energy that comes to our planet that's picked up by organism is lost as heat. However, we do have the ability to grab some energy, and that's useful. We use it to chew our food, to walk around, to do the chemical processes of living things. So, the bottom line, in kind of a quick summary, ecosystems require a constant flow of energy. The energy always originates from some non living source. Photosynthesizers use sunlight to do photosynthesis. Chemosynthesizers, which we're not really going to talk much about, chemosynthesizers get energy from other compounds. And then consumers, or heterotrophs like you and me, we get our energy from those chunks of biomass that are created by plants that get handed down to us, whether we're eating meat or whether we're eating some kind of vegetable material. So, energy is required in ecosystems.